Hi everyone, let's solve this interesting geometry problem together. As you can see, there is one function below, which is the function f of x equals x squared. And then there is this blue function above, which is g of x is equal to the square root of x. As you might know, these are inverse functions of each other. And the problem states that there is a square that lies exactly between these two functions. So we mean that all the points, all the corners are on these two functions. So let's solve this. Let's first map some coordinates on these points so that we can use all this information that is given. So let me call this one A, this one B, and this one C. And let me pick some variable t, which is the x value of point B, such that point B becomes t, t squared. Now notice that because of the symmetry, B and A lie on exactly corresponding points of these inverse functions. So which means because the square root of x is an inverse of x squared, that means that these coordinates are for the x value t squared and the y value t. Now the only problem is point C. We have to know what the coordinates are of this point. But for this we are going to use a trick, which is that we know that this diagonal is exactly the first bisector of this plane, which means that this angle is equal to 45 degrees. And now because of the symmetry in this figure, we see that this is a right angle and this is a right angle, which means that these 2 points A and C lie exactly on a vertical line, since we know that the angle of a square is 90 degrees, so that this angle is also 45 degrees. I hope you can see that. So this means that the x-coordinate of C is equal to the x-coordinate of A, which is t squared. But now we know that C lies on the yellow function, which is x squared. So as you might guess, the y-coordinate of C is equal to t squared to the power of 2, which is t to the power of 4. Now our goal is to find the area of this square. So a good way to do this is to try to find this value of t. And I will show you 2 ways to solve for this value t. Now the first way to solve for t is to notice that this is the midpoint of C and A, and that the y-coordinate of this point is equal to t squared. So we get that t to the 4th plus t over 2 must be equal to t squared. And then it follows that t to the power of 4 plus t is equal to 2t squared. And now we're going to use a trick, which is that we can write this as t to the 4th minus t squared is equal to t squared minus t. But now notice that we can factor this left part of the equation, which gives us that t squared minus t times t squared plus t is equal to t squared minus t. And since t squared is not equal to t, because then t should be 1, we can divide by t squared minus t by that factor. And this gives the equation that t squared plus t is equal to 1, which is our first way to get to this result. Now we could solve for t immediately, but we will see that there is an easier way to find the area of the square. But let me first show you a second way to arrive at this result, which in my opinion is a cooler way than this one, but it is a bit more difficult. And the second way uses complex numbers, and the property that multiplying by I in the complex plane gives you a rotation over 90 degrees. So let's use complex numbers and put an I here. A second way is to first see what this vector is, which I will call vector R1, and then look at this vector, which I will call vector R2. And now as complex numbers, we have to have that R1 times I, which is the square root of -1, must be equal to R2 if you write them as complex numbers. So let's do that. My coordinate B corresponds to the complex number t plus I times t squared. The coordinate of C corresponds to t squared plus I times t to the power of 4. And my coordinate of A corresponds to t squared plus I times t, where t is the value we want to solve. But now vector R1 we can write as the difference of the following complex numbers, which is the endpoint, which is B, minus the starting point, which is point C. So we get that vector R1 is equal to t minus t squared plus I times t squared minus t to the power of 4. And now this whole quantity times I gives me a rotation over 90 degrees, which gives me exactly vector R2. So this should be equal to R2, which is point A minus point B. So point A minus point B is t squared minus t as my real part of the complex number plus I times t minus t squared. Okay, now let's see what this gives us. Imaginary parts will cancel out, since t minus t squared times I is equal to I times t minus t squared. So we are left with I times I, which is negative this expression, so t to the 4th minus t squared, which must be equal to t squared minus t. And then by the same trick, we get that t squared plus t must be equal to 1. So let me now clear the board and solve for the area that we want. Okay, we are ready to solve for the area. Let's first try to find an expression that represents this area, which is as simple as possible. So I suggest we look at this as a diamond, such that the area is just this diagonal times itself divided by 2. So that gives me that the area is equal to t minus t to the 4th, this whole quantity squared divided by 2. And let's now try to use these equations to simplify this expression. So t to the power of 4 is equal to t squared squared, so that this becomes 1 minus t squared over 2, which is equal to t minus 1 plus 2t minus t squared, and this whole thing squared divided by 2. But now this t squared is equal to 1 minus t, So this becomes t minus 1, 1 plus 2t minus 1 minus t squared divided by 2. So we get that this is equal to 4t minus 2 squared over 2. And this is equal to 2 times 2t minus 1 squared. And now I stopped here because there is a clever way to find the value of 2t minus 1. And we are going to do this by looking at 2t plus 1 squared, which is equal to 4t squared plus 4t plus 1. And this is 4 times t squared plus t plus 1. But now we know that t squared plus t is equal to 1. So this is equal to 4 times 1 plus 1, which is 5. So it follows, by taking the square root, that 2t plus 1 is equal to the square root of 5, so that 2t minus 1 is equal to the square root of 5 minus 2. And now let's combine these answers to get the area. So the area happens to be this expression, but we can substitute 2t plus 1 by square root of 5 minus 2 to get that it becomes 2 times the square root of 5 minus 2 squared, which is 2 times 5 minus 4 root 5 plus 4, which is exactly 18 minus 8 root 5. And this is our final answer. Now, if you like this geometry problem and this video, don't forget to subscribe and see you next time.